line and angle relationships. In this video we'll look at parallel, perpendicular, skew lines, and we will see how they relate to one another when you're trying to find unknown measurements in a diagram. First, let's understand some vocabulary. Perpendicular lines, two lines that intersect in any way to form right angles. Parallel lines, the most common example would be like railroad tracks. They will never intersect. They stay that same distance apart the entire time. Skew lines, these are lines that are on different planes. This is when we need to think three-dimensionally. First of all, they are not parallel, and they will also never intersect. Adjacent angles, they have a common vertex and a common side, but no common interior points. Think of this like two rooms in your house right next to each other. They share a wall. That's kind of like adjacent angles. Vertical angles. The best word to describe these would be opposite. Think about sitting at a circular table with four people. Who are you opposite of? Now, if you divided your table into four sections like a pizza, into four slices, think about opposite slices. That's what vertical angles are. In a transversal line, this is a line that intersects, cuts through two or more lines. Let's take a look. Here's a three-dimensional object, a rectangular prism, but there are lines continuing in each one of the vertices. Parallel. Well, just to show you a few examples, this top line going across the back of our figure here is parallel to the bottom line. They will never intersect. They are parallel. That top line could also be parallel to this bottom line on the front. There is more than one correct answer here this is an activity in a class. As long as they are parallel, the same distance from one another, and will never intersect, that should be a good answer. How about perpendicular? Oops, let's be a little bit more accurate. If we focus front to back, the depth of our object here, in the top right line, we need to look for an angle that would make 90 degrees. Now we're looking at this image from the side, but there is technically a 90-degree angle right across the top of the front here. So those are 90 degrees. Pretty much any corner you want, even if we go top to bottom, it would also be 90 degrees. Much like getting a shipment from UPS or FedEx, most of the time those boxes have all perpendicular angles. And what about skew? Skew, now these are on different planes, they're never parallel. Let's focus in on this vertical edge right here. Another side that we could highlight that is not parallel. In order to not be parallel, we just don't want any other vertical corners. Let's just stay away from the corners of this figure. But we don't want it to intersect either. Well, what if we chose front to back the depth of this one here, WX? These two lines, imagine a hallway in a building and an elevator. The hallway and the elevator will never intersect. They are not parallel. They go in different directions. These are examples of skew lines. So how do all of our rules now that we've learned about angles and lines and how they intersect, how do they all relate to one another? Well, in this diagram, we're given 130 degrees. Well, we talked about a straight line being 180 degrees, and we see this straight line, this transversal line, cut straight through the center. So if this whole angle here is 180 degrees, why can't we subtract the one that we know, the 130, out of it to get our answer for angle number 1? 180 minus the 130 that we know gives us 50 degrees. So angle number 1 is going to be 50 degrees. Now we see 50 degrees somewhere else as well on the other side. 50 degrees is over there. But what do we know about angle number 2? I know we didn't need to figure out angle number 2, but this would be an example of vertical angles diagonally across from one another. So angle 2 would be 130 degrees as well. Well, if we know that angle 1 is going to be 50 degrees, what's angle 1's vertical angle? 1 and 3 are diagonally opposite of one another. So angle number 3 would also be 50 degrees. And using that idea of vertical angles, 50 would also be a vertical angle with the 5 over here, which is another one of our answers that we need. Angle 5 is also 50 degrees. And if angle 5 is going to be 50 degrees as well, how do we find angle 6? Well, remember, a straight line minus the 50 that we know for angle 5, 180 minus 50, we're back to that idea of 130 degrees. So angle number 6 is going to be 130 degrees. Now if we take a look at this diagram, we have 4 acute angles, 4 obtuse angles. One quick trick, as long as lines N and P are parallel, 4 of our angles are going to be 50 degrees, 4 of our angles are going to be 130 degrees. They make a checkerboard kind of pattern as you're walking your way through this image. So let's take a look at one last example here. 52 degrees. It's an acute angle. Its vertical angle, the one diagonally across from it, would be angle 7. Angle 7 is also 52 degrees. Let's find the other acute angles. Well, using that checkerboard style pattern, I can tell you right now that it's going to be 52 degrees for angle 2, 3, and 7. The other angles that we have not circled would be 1, 4, 5, and 8. How many degrees would those 4 angles be? Well, we know that they are obtuse, and we know a rule: when we have a straight line, 180 degrees minus 52, 180 degrees minus 52, whatever we're left with should be the obtuse angle that we're looking for. So when we borrow and we subtract, we find that these 4 angles would be 128 degrees.